All right, we're looking at lesson set 19, full screen. The last lesson set made too many careless errors. I can live with one or two, but if I get to three, I get upset. So I did mental math. I just finished 48 problems, 47 problems, something like that. And I'll eventually get the worksheet in front of me. I should remember to put that in my pocket because sometimes I erase something and I wonder what I'm looking at. But if you're getting these, this is lesson 19 and a lot of repetition here. If you're getting the first 20 or 30 problems mostly right, then you should do these in your head. It's good practice. And so that's what I've done. So that'll be my check when I do the problems out. And you can scan. I've got all the answers. The only one I had trouble with, I forget what it was. There was one that I'm like, I don't feel too confident. I was probably towards the end of the video when it started getting a little tired. But as I say, try to mental math as many of them as you can, just to challenge yourself, especially anything you're getting right. And after checking, if you want to kind of stream through this in different places, the answers are on the board. And modern technology, I'm telling you, I figured out how to move the cursor and go different places in the video. Oh, it's amazing. All right, so let's have at it. So the first one was up. I'm over here. Come on, Renee. Uh-oh, banging into things. Better call Geico. All right, so equation of a line, I see -5, 2, so I wrote x plus 5 plus 2. And I looked at -5 to 9 next, I wrote 14. 2 to -17 is down 19. I feel good about that. Mx plus b form, so I don't have any problem writing -4 7 x. So I looked at -4 times 2, which is -8 and 35, -8 and 35. Doing it in my head again. 27 sevenths is what I wrote before. 3 coordinates. I start with -2, then I fill in the left side of the table by changing by 7. So -2, 5, 12. I drop 12 in to see if it's a multiple of 7. 7 goes into 14 twice. I feel good. Then I put a 5 down. I went down 4 twice. So I should have a 1 and a -3. So that felt good to me. This one here, if you're going to do it in your head, you got to recognize you're multiplying by 15, and this will become 5 times bigger. This will become 3 times bigger. So I did 5 times -5, -25. Over here, I have -9. I'm going to bring the -25 over to this side. It becomes +25 minus 9, which is 16, and I know that's going to be a division. So I wrote 16, and then I knew that this would not cancel. It became 30. That becomes 15. I took that 15 away from this 30. That's what I got for that answer. All right. I don't think, of course, I said I'd get an eraser here, and I don't have it, so I'll use this paper. All right, and I said that fast, and people have trouble with this, so let's do this one out. Well, let's do both of them out. All right, so there's your -4 7 x. There's your -8 sevenths. There's your +35 over 7. I'm writing 5 because I'm talking again rather than just doing the problem. All right, I hope that leads you to believe that that's correct. We're going to multiply this one by 15. Well, there's your -25x. There's your 30. There's your -9x. And there's your 15. Yeah, I should check these. Okay, so I can see the 15 take away makes 15. That takes care of that. -25 becomes +25, which should be 20. Ooh, yes, 16x. And then I guess you divide by 16. So that looks pretty good. All right, so I just wrote the answer here because I've done this problem so many times that I know that the perpendicular is staring me in the face. I hope you can see -5 over 2 staring you in the face. But -5y equals -2x plus 37, which is a constant. Not worried about constants. They're not affecting rate of change. Y equals 2/5. X is the original slope, and perpendicular is the negative reciprocal. So now f of -3/4. Given a function, f of x, I'm going to multiply this number by -3. So it's going to become 9/4 minus 36/4 when I get done. That's going to be minus 36 fourths, and 9 minus 36 is minus 27 fourths. That's what I got. Okay. This month, I don't know if that was the one that gave me trouble or not. I do know the denominator is 41. By squaring 4, you get 16 and 25. That's always going to happen. So I don't have to worry about the denominator. The numerator, well, I'll show it. I'll show it. So I said 41. Good, I got 41. And so now I'm going to have to multiply by 4 minus 5i. So in my mind's eye, I have a 4 minus 5i here. Let's see how I did. Let's do the denominator first. Okay, that's the number 1. And 1 times a fraction doesn't change its size, but it does change its look. So you can do this out. The middle terms cancel, and you get 16 minus 25i squared, which means this is always going to be a positive number, because if it was a minus and a plus, it would still be minus 25i squared. But it was a plus and a minus. So in the mind's eye, we'll do this later, I'm trying to multiply that times that. So I see 20, and I know that's going to be positive 10i squared. So I've got 20 minus 10, I believe, 20 minus 10, and I hope I wrote 10, I did. And then I've got the middle terms, I can see those more easily. Minus 8, minus 25. Of course, that's in the mind's eye. Minus 8 minus 25 is minus 33. Okay, yeah, I started that. That's the one that took me a little time. All right, but let's do it out. 5 plus 2i. All right, we did that already, so let's just do the numerator. There's your 25. There's your positive 10i. There's your minus. Oh, I made a conjugate out of the numerator. See how I make mistakes when I start talking. It's 4 minus 5i. 5 times 4 is 20. Oh, Lord. It's tough to get old. 5 times minus 5i is minus 25i. 2i, negative 2i, so minus 8i. And then positive 10i squared. What's 10i squared going to become? Minus 10. I squared is negative 1. Oh, there's your 10. Here's your minus 33. So I feel good about that now. I started. I wasn't so sure. Okay, this one here, I wrote the center. So we're doing a circle, right? We're doing a circle. And I wrote that the center is negative 1, 2, and the radius is 7. And I hope you get to the point where I get a lot of students who can do that before midterm. All right, so what are you going to do? You're going to write x plus 1, right? So what's the center going to be? Negative 1. You're going to write y minus 2. So what's the center going to be? Positive 2. What do you get when you square a minus 1? You get 1. What do you get when you square a 2? You get 4. What do you get when you add that to 44? You get 49, so the radius is 7. Now I'll do it all out. Completing the square. X plus 1 squared minus 1 plus y minus 2 squared minus 4 equals 44. That gives us the Pythagorean triangle. That's the area. Side length x plus 1. Other side y minus 2. Radius 7. As one area gets bigger, the other area gets smaller because that area is a constant. And that's what gives you the rotation, the circular rotation. And so when I bring those numbers over, minus 4, minus 1, add 5, there you go. 49 is 7 squared. There's your picture. All right, so we did that one. So I said, what's the vertex? All right, well, I did minus b over 2a in my head. Minus 20 divided by 4, I said minus 5. I plugged minus 5 into the middle term, cut it in half, and subtracted 7, and I got minus 57. So let's take our time with it now. And that's what I wrote. All right, so minus b over 2a. Minus b. Minus 20 over 2 times a. 2. Minus 5 is correct. Plug minus 5 in, you get 50. Minus 100. Minus 7. 50 minus 100 is half of minus 100. Minus 7 is minus 57. So that was your vertex. Now I want to write a quadratic. 0, 5. Well, I don't need to write x minus 0 squared. I just wrote x squared plus 5. So now the question is, how do we get from x squared plus 5 when I throw the number 10 in? Well, what happened to my number? it became 100 plus 5. I don't think that's 8. I don't like that 100. I'm going to get rid of that squaring because I know how to get from 5 to 8. Add 3. Done. I don't know why I wrote 8x plus 17x squared. I'm not trying to check anybody. 17, fool anybody. 17x squared plus 8x equals 0 is how you should be reading that. All right, so what are my answers? I can see 1 is 0, and then if I cover up 1, I can see negative 8/17. All right, so what did I do? I factored out the common term. Plugging in a 0 makes a 0 in multiplication. And then I let 17x plus 8 equal 0. And I hope you're starting to do those in your head. Subtract 8, divide by 17. All right, 9i to the 18th, doing it again, I'm seeing negative 9. Why? Because 9i squared, which is negative 1, I'm doing 9 times. That's another way of writing that. And another way of writing this is 9 times negative 1, 9 times. And if you don't know what that is, why don't you do it out? Do 9 of them. And find out why your answer is negative 9. 7 plus 4i squared, binomial squaring, gets us the first and last term squared. That's 16i squared, which is going to be minus 16 from 49 is 33. Good. And the doubling of that, 28i, should be 56i. Good. Okay, what did I do? I squared the first term. I doubled the product, 28, 56i. I squared the last term. And I know what that is. It's minus 16. Binomial squaring. Let's do the same thing. Let's call x to the 5th, y to the 4th, the letter n. Let's just say that's n, okay? Let's say a times b times c. Let's let b times c equal n. Then wouldn't this equal a n? Okay. Could have said that better, I'm sure. Squaring the first term. It's the same problem we did here, except we don't have to deal with I squared. Square the first. 64x10. Square the last, positive. 16y8. Right? Minus 4y to the 4th is going to be in the back end of 2 parentheses. If I wrote the parentheses, and a minus times a minus is a plus. And 4 times 4 is 16. And y to the 4th times y to the 4th is y to the 8th. And now let's double our middle term. There's x5, y4, think of it as n. But you have minus 32, x5, y4 doubled. Minus 64, x5, yn. Yep, that's what I had over there. Except I wrote n here. There you go. All right, if I'm not talking and just working, I do a lot better, I think. All right, so 0, 0, square root. Square root start at 0, 0, so I can simply say square root of x. Put a 0 in, you get a 0 out. Now what happens when you put a negative 9 in? It's undefined. Well, I want it to be defined, so I'll turn the negative 9 into a positive 9. Now when I put negative 9 in, I get the opposite of negative 9, which is 3, and now I have a square root function. If I get rid of the 3, no, I didn't want to do that, I didn't want to show it. Well, it's going this way. Right, 3, so I'm going from 0 to 2, so it's actually going up in this direction. But I don't want 3 units of change, I want 2. That's my function. I get a marker. It's very empowering. I get to do what I want to make things work, to make an equal sign. Yes, if I put 0 in, right, I can't put positive numbers in. They're not going to, square roots and negatives aren't going to show up on René Descartes' coordinates, are they, René? René said, no, they're not, right? That's an axis that comes out from the wall. I don't like that axis because I do think there's something to be learned about flipping quadratics over and having the same x values, getting the same amount of change, but just imagining that's flipping over. All right, so where was I? Done. Okay, looks good so far. There's nothing you can do with this. The only thing you can do is write the answer. You take the cube roots, 3x minus 5y. Your next parentheses, there's no thought involved. It's just working with these two numbers. That's one dimension of a cube. Right? Whose volume is given as 27x cubed. That's one dimension. I got to get back to this. I got to multiply by those other two dimensions. I got to get 3x times 3x involved, which is 9x squared. I got to get cancellation, otherwise I'm going to have too many terms over here. And it turns out the cancellation is simply changing the sign and multiplying the two. 15xy, that's pure effort on your part. Squaring the last, we just talked about squaring the last term, you always get a positive. And that's going to be 25y cubed, y squared. And hopefully that's what I wrote. Next problem. Well, I'm hoping I can factor this. So the first thing I look at is 77 and see if I got two factors that are 4 apart. And 7 and 11 are. So I put 7 in first and immediately see that didn't work. So I threw 11 in. And 11 did work, which means 11 and -7 are your answers. But to get there, x squared minus 4x minus 77 equals 0. Okay, let's erase that for spatial purposes. So I know I've got a 7, and I know I've got an 11, and I know I've got a middle term that's negative. So therefore, I want the bigger number to get the negative and the smaller number to get the positive. And then I can see -7, 11. I just took a shortcut because I knew it had to be plus or minus, and I didn't feel like thinking. When you think, you make thinking exercise mistakes. If you don't think, you can't make a thinking mistake. I have no idea if that makes any sense. All right, 3x squared plus 10x minus 8. Again, this much I knew, so I wrote that down on the answer key over here. And then I thought to myself, what factor of 8 gets me close to 10? And I threw a 4 down there, and it just so happens that 12 and 2 are 10 apart. I want this to be positive, so I make that positive, that negative. I didn't set up an equation, so I do not want to see 2/3, comma, -4. It tells me you knew how to factor it, but this was not an equation set to 0. So what's another name for this? That's another name for this, which is helpful because what if I had to divide by x plus 4? Well, then I know my answer is 3x minus 2. Comes in handy sometimes. All right. 18, x minus 4. I cheated a little bit. I want to get minus x, so I simply wrote x plus 3, right? And then I just threw 4 in because I didn't really want to think. And I got 16 minus 4 plus 17. 12 plus 17. I knew my answer was x plus 3 plus 29 over x minus 4. Yeah, the critical number over here, because remember, I could have put the 29 on the outside. And if I have something that I make a 0, then 0 gets rid of that parentheses and gets 29, which means that 4 got me 29 because that's what made a 0. 4 gets me 29 on the left. Well, if that's the same calculation, 4's got to get you 29 on the right. So I checked to see if it did. 33 minus 4 in my mind's eye, 29. I wrote the answer. Now let's do it out. Let's pretend we didn't have the answer. Well, to get, I erased it. Well, x squared minus x, and I got, now I got to think. Okay, we're not going to do it out, but we can at least do this much out. We got to get 3 here, so that had to be minus, that had to be x squared minus x, right? So I hope you can see why I'm starting there to get the first 2 terms. Okay, and I'm sure if I took a moment, thought about it, come up with it, but I'm not going to waste your time. So there's nothing you can do here. People start multiplying this out, and I have a good time letting them do it. When they first do it, I just let them multiply this out, takes them 10 minutes, and then I just say, well, that's your answer. 0, -4, 2. Because if a product equals 0, then one part of the product has to be 0. So what makes that parentheses 0? 0. Didn't have a parentheses, but if I put 0 here, 0 times anything 0, what makes that? -4. What makes that 0? 2. That's all you got to do. Write your answers. All right, I forgot to do mental math, so let me get those up real quick. 21, I'm seeing 2, I'm seeing a 7. I'm seeing x8. I'm seeing y and a y there. 22. It's cube root, so I'm seeing, well, I need more space. I need a 5. I need, well, I guess I should which way do I want to do this? Let's do it this way. So I've made 125, so that's got to be a 2. That's not multiple of 3, but 45 is. 45 goes 15 times. Which means if I multiply that by 3, I'm at 45. I need one more x. 29, 3 goes 1 less, 10 is 30, right? So there's a remainder of 2 in here. And 27, 3 goes into 27 9 times. Now, I would explain that more, but getting tired, so let's just keep going. All right, so this was bingo, bango, bongo. And so I'm going to write my answer over here. And so I've got 3 times x is 3x, 2x times 2x is 4x squared. So I don't see any like terms coming out of this. X squared. So I've got 4x squared. I've got, what did I say? Minus 14x minus 3x. I'm going to get minus 3x minus 14 minus 3 is minus 17x. This is one of the harder ones to do in your head. And then I've got a minus 3 on that side. I'm subtracting 3. And I already have, oh, that's changed. So I'm just subtracting 3, I think. And then in the denominator, I'm going to leave it as 2x times x plus 1. Check that out. I don't think either of those are factors, so maybe I multiply it out. What's a good number to plug in here? How about 4? No, 5. No, 6. Not finding anything easy to plug in. So let's do it out. And let's check it by doing it out and seeing if the mental math held up. So let's do bingo, bango, bongo. 2x times 2x, 4x squared, 2x times minus 7, minus 14x. 3 times x plus 1 is 3x plus 3. And then I've got my x plus 1 times 2x here. Okay, that's not a problem. I got 4x squared minus 3x. Oh, I made a big boot. No, I've got minus 14 minus 3. Oh, that's good. Minus 17 did hold up. And minus 3 holds up. I think I'm okay. Okay. X minus 7 over 7 minus x. It's not the first time you've seen it, so I'm just putting it back there as a refresher. So, you know, let's plug a number in. Let's plug 10 in. 10 minus 7 over 7 minus 10. I'm seeing negative 1. I'm going to remember that in case I ever see these factors show up again. And you will. It'll be on your test. All right, so back to some that I remembered to do. All right, so in my mind's eye, I'm seeing 2, and I'm seeing minus 4. I'm only seeing one answer. All right, so what am I going to do? I'm going to square this, so that's x minus 2. Over here, I've got x squared. I don't worry about that. Over here, I got minus 2. On this side, I'm going to have minus 8x in the middle. And minus 8x plus 2x is 6x in the middle. So right now, I've got x squared plus 6x, and I'm going to end up with 16 plus 2, 18. God. So I lost my sight on that one. I did get an answer before at 7 when I was computing, just looking at it and being quiet. I'm talking to you now. So let's just do it out and see if x equals 7 was going to work. Well, we check it. 7 minus 2, that's not going to work. Square root of 5. So maybe I wanted a 9. Sure seemed like I had 18 there. 9 minus 2. Nope. 9 minus 2, 11. Nope. I'm going to do it out. I'm having trouble with it. All right. So I've got x minus 2 at this stage of the game. I've got x squared minus 8x plus 16. So I was right about the 18 a minute ago. And I've got minus 2x, adding 2x is 6x. And I've got x squared plus 6x plus 18. Oh boy, do I have a completing the square? Huh. 6, 8, 9, 10, 11, 12. Yeah, I guess I didn't make the problem that I was. I guess I buried a completing the square in there for you. So this is a little challenging now. So we got x plus 3 squared minus 9 plus 18. So that's going to become, I don't want to erase this one. I'll erase that. So this is going to become adding, I'm setting this to 0. So this is actually going to be negative 9 on this side. Maybe I better get that one and check that one out. Yasser, you got one to do there. All right. I did definitely botch that. It was x minus, I don't remember what I got to remember not to not to erase an original. So I'm gonna do this one out because now I'm perplexed. 26. Square root of x minus 2 equals x minus 4. X minus 4 has a y-intercept of -4 going up at 1 to 1. X equals 2 is to the left of that line. And so it looks like I should get an answer near 5. Okay, so there does appear to be an answer here. So therefore, I think I can squeeze this in. So x minus 2 equals x squared minus 8x plus 16, making that 0 gets me x squared minus 9x, adding 2 to this side, 18. All right, and 9 and 2 work. Okay, so sorry, folks, took me a while. So I've got x. No, 9 and 2 don't work. X squared minus 18. Factors of 18. Boy, my brain's slowing down right now. 2, 9, 3, 6. Okay, so it's 3, 6. Of course, negative in the middle, positive at the end. Had to be negative, negative. Oh boy. X minus 3, x minus 6. Only 6 is going to work. 3 is fictitious. Right, so 6 should work. 6 minus 2, 4. The square root of 4 is 2. 6 minus 4 is 2. So that worked. Sorry, got really waylaid there. Tired brain. That's what happens to me now. Get tired. So this one here, so x equals 7 was wrong, should have been 6, been corrected. Okay, so in the mind's eye, I'm seeing a root 3 buried in this, so I'm seeing 6 root 5, which I wrote. Over here, I'm seeing 9 gets me root 5, right? Minus 15 root 5, but I got to multiply that by root 3. So I'm getting minus 15 root 50. Okay, good. All right, so what I'm seeing here is square root of 3 times 2 times the square root of 3 times the square root of 5. That's another way of writing this. Minus, I think I can erase this now. Minus, I'm seeing root 3. Now I'm looking here. I'm multiplying by, I've got the minus already taken care of. I'm multiplying by 5, and I'm writing 45 as the square root of 9 times the square root of 5. So there's my 15, there's my minus 15, there's my root 15. Okay, so that was done properly. All right, I have answers of negative 6 and 10. Let me tell you how I got that, then we'll do it out. So I subtracted 9. I had minus 24 in my head. I divided by negative 3. I have 8. Doing the absolute value gets me plus or minus 8. So I know I'm moving from 2, 8 units. And so I wrote 10. And I know I'm moving backwards 8 units from 2. I wrote minus 6. And that's exactly what happens here on the next step. So 10 and minus 6. So I add 9. It's gone. Minus 15 is now minus 24. I divide by minus 3. It's gone. It's gone. It becomes 8. I do the inverse. I did the inverse of addition and subtraction, inverse of multiplication, inverse of absolute value. You can get away with plus minus in this instance. Okay, and then minus 2 becomes positive 2. And that is that answer. All right. So the only way you get 6 out of this is if e to the x minus 4 equals 1. So I knew the answer was 4. If you're doing it with inverse operations, then you subtract 4 from 6, you get a 2. Multiplication becomes division. E to the becomes ln of 1 is 0. You add 4, and that's your answer. 16 and 8 have base 2 in common. So I know the fourth root or the fourth power gets me 16. I don't want the fourth power. I want a third power to get the number 8, and I want to flip it. So that's what I have. So 16 to the x equals 1/8. What did I do writing it out? I wrote that as 2 to the 4. That's another name for 16. I raised it to the x. 1/8, 2 to the negative 3. I don't think I have to show you why at this stage. Therefore, 4x equals negative 3. I don't want power of 4. I want a power of negative 3. So negative 3/4. Okay, hopefully I haven't lost any of these on the screen because I have not been paying close enough attention to whether everything's centered. Okay, it looks good. All right, so same thing here. You're going to flip it, get 49. You're going to take a square root. You're going to cube 3, 7 to the 3. And I remember doing that 2 weeks ago, and I remembered it was 343. Then I remembered doing 7 times 50 and 7 times 49. I did that one in my head first, 350. 1 less 7, 343. All right, so let's do it out. First thing, I'm going to do the minus sign. That means I'm going to flip this and get 49 over 1. Don't really have to show the 1. Then I'm going to take the square root. Square root of 49 is 7. And then I'm going to do 7 to the 3 to get that answer. Okay, this is gone, gives me a workspace. All right, so I know I'm going to work with base 3. And mine is going to be negative 3. So I'm multiplying x by negative 3. And I'm multiplying 9 by 2. So that's 6x over here, negative 3 over here. I'm going to bring the negative 3 to the other side, add it to the 6, and then I'm going to divide. So I wrote 9. Trying to explain what I did in my head. So negative 3 times negative 1 is positive 3. I've got a 2 over here. I moved everything to the right, so I got to move the constants to the left. You take 2 away from 3, and you get 1. All right, let's show it now. 1 over 27 is 3 to the negative 3 to the x minus 1. Equals 3 to the 2, that's 9, raised to the 3x plus 1. The exponential activity has to be the same. So over here, I've got minus 3x plus 3, and over here, I've got 6x plus 2. As I said, I'm taking 2 away from 3 to get 1. I'm adding 3 to 6 to get 9, and I know that coefficient is going to be division. All right, so moving on. At this stage of the game, you should know your answers to this. This is about what are the roots, and the roots are 0, which is well below 7. Your answers are imaginary. Okay, what are the steps? Measuring from 5, plus or minus in either direction. Flipping the thing over is what I is all about. And I've got to travel 7 units, but I got a multiplication by 2 and a square root because I got to undo squaring. All right, so where do I get that? Well, this is AHK. This is exactly what you write in graphing form. That's the graphing form, and we're going to set it to 0. Well, A is given, it's 2. H is given, it's 5. K is given, it's 7. Well, you tell me if you follow minus 7 divided by 2, plus minus the square root of 7 over 2, imaginary. 5 plus or minus the square root of 7 halves, imaginary. Certainly doing it enough times, but you're the one that has to pause the video if you're not getting it, look at it several times, try to process it. And then you don't have to work. You can just write an answer. I hope I wrote the, okay, looks like I did, checking my answers. I don't think I'm making a lot of mistakes at this point. I got a little bit of a double check. The only problem with the double check is I'm doing the problems the same way I did them the first time. And I don't trust that 100%. Because if I made a mistake the first time, I'm liable to make the same stupid mistake the second time. That has been proven time and time again. All right, so that's done. What did I ask here? Inverse. So this is about the inverse of g of x. So I'm going to make a function. I'm going to make a function, and I'm going to start with x, which happens to be the answers to this equation, if I put a number over here. And I'm going to start with those answers and work my way back. I see addition of 3, subtraction of 3. I see multiplication by 4, division by 4. I know the inverse of 5 to the is log base 5 of the. I didn't leave myself much room here. 34. No, 32. All right, where was I? No, I'm doing this problem. Yeah, so subtraction of 3, making sure, yes. Oh yeah, I got addition of 7, so I'm going to subtract 7. And it's easy to make a mistake, so you check your answers. What would be a good number to work with? How about negative 6? Negative 6 plus 7 is 1, that gets me 23. Negative 6 gets me 23. 23 better get me negative 6. 23 minus 3. 20 divided by 4 is 5. What do you put on top of log base 5 to get a 5? What do you put on top of 5 to get a 5? A 1. 1 minus 7. -6. Did I write the, yep, I wrote the same thing first time through. So that's gone. I'm hoping the repetition catches somebody who may not have been thinking about these problems throughout the first 2 months of the term. If you haven't been thinking about these problems, I wonder why. But better late than never. 4 more tests. Couldn't have a test today. Got one Tuesday, Friday. No more new material, but everything that you've seen thus far could be on the next 4 tests. All right, you got some goalposts. You know what scores you got to get. So you know what grade you want the grade you want. Hit the scores we put up there for goalposts, and hopefully you'll get there. So what did I write for an answer of 35/8? Let's find out if I'm right. All right, so I only see multiplication here, so that's division. If I divide -15 by 5, I get 3. Now I'm going to do the inverse of log base 2, which is 2 to the, and 2 to the 3 is 8. And I'm going to multiply 8 by 3, which is 24. And then I've got to subtract thirds. And -4 is 32 thirds, so 33 times, now this is where I might have gotten a mistake because I'm talking to you, I've already lost my train of thought. So net 5, that is -3, isn't it? 5 into -50, see, I already made a mistake. -3. All right, 2 to the -3 is 1/8. 1/8 times 3 is 3/8. This is what I'm doing in my head over here. And now I'm doing eighths, because that's why I remember doing eighths, and I was doing thirds here for a second ago. So 4 times 8 is 32, and it's negative on this side, so it's going to be positive 32 on that side. And I do believe 35/8. Yes, that checks what I did before. All right. So I hope that you followed this line of reasoning. 5 into -15, that's gone. I don't want to keep writing it here. Log base 2 becomes 2 to the. 2 to the becomes 1/8. That's gone. Multiplying by 3 makes this 3/8. That's gone. This is gone. Adding 4 to this on that side means we're back to what we were doing with changing linear function into slope-intercept form. That's 32/8, hence 35/8. Okay, it's good practice doing them in your head. Almost done here. We got 2 more columns to do. So yes, I have a f of x here, but it has no bearing on this question. I want g of x, which could have been written as g of x. Well, I got another name for g of x. It's right here. And so instead of writing g of x, I'm going to write x squared plus 5. G of x squared plus 5. What's the g of x ask me to do? G of x asked me to take my numbers, square them, and add 5. So I'm going to take my new number, x squared plus 5. That's what I'd have if I let x equal some number. I'd square it and add 5. That's going in here. I'm squaring that. We're getting better at binomial squaring. X to the 4 plus 10x squared plus 25 plus 5. I guess I didn't do this column, so I'll just do it out now. Got tired, I guess. So what's my answer? X to the 4 plus 10x squared plus 30. I can't imagine why I didn't do these. So this one's 40 divided by 2, 20. So we got 2 root 5 plus or minus 2 root 5. Let's see if that works. I can erase this up. I didn't do these problems. Oh, I don't know why I erased. I remember doing that problem. Oh, all right. I don't know. I erased it for some reason. The answers. Don't know why. Had these already done. All right. So what am I going to do? I'm going to multiply this by 3 so that I get a positive 3y. That's going to cancel. So that means I have 15 and 3 is 18. I know that's going to be a division. Now, this column's gone, but I multiplied by 5 up here. No, just 3 here. That's all I had to do was 3 here, right? Cancel that. So that means I got 57 and 15, 67 and 5. I should have 72 over 18, which is 4. I don't think I had that the last time. Well, let's get a 4 in here. Then y would have to be 1. Put a 4 in here. 12 minus 3. 12 minus 3. So I made a mistake somewhere. I figured I might. I make more mistakes on this problem than any other because there's so many calculations and I'm in a hurry all the time. So I'll slow it down because I definitely made a mistake, I think. 5x plus y. I am going to use the whiteboard here because of time. So I hope you see why I want to multiply this by 3. Okay, if I do that, then I end up with 15x here. Multiplying by 3, I get 3y there. And multiplying by 3, I get 57. I don't think I botched that so far. If I add these up, I get 18x. Those cancel. 67 and 5 is 72. And 18 does go into 72 4 times. Okay, so what did I do wrong here? 20 minus 1. Oh, I think I said positive 1. So there was my mistake. Minus 1. Minus 1 works. 3 times 4 is 12 minus 3. Oh, minus a minus. I almost made the same mistake again. Writing it out. All right, so I'm confident in that now. That was good. That was good for me to make a mistake and go back and find it. Maybe I won't make it the next time. What practice is all about. So I'm seeing a root 5 here. I'm seeing a root 5 here and a root 5 there. So I've got root 5s as an answer. Yeah. I mean, why can't we add 1/2 and 1/3 the way it's written? They're not the same division. Why can't I add x squared plus x? They're not the same exponent. Why can't I add root 2 plus root 5? They're not the same radical. But what if I had 3 root 2 and 4 root 2? Well, yeah, I've got 7 root 2s. I can count those. They are the same. So that's what dictates addition and subtraction likeness. Like terms. That's why you hear the expression like terms. Adding and subtracting, like terms. So I'm seeing square root of 4 times 2. Well, let's do it out. 5 root 4 root 5 minus 2 root 9 root 5 plus 4 root 5. Okay, we can count them now. That's 10 root 5. That's minus 6 root 5. That's 4 root 5. Oops. Talking and not writing properly. Okay, so that's 4 root 5 plus 4 root 5 is 8 root 5. That's that answer. All right. Did I do 2x squared minus 40? I think I already did that one. Well, you're going to move the 40 to the other side. You're going to divide by 2. You're going to take plus minus square root. I will accept plus minus the square root of 20. You got so many problems. And I'll just put a little circle around it, saying that I hope you're right 2 root 5 the next time. But I'm not going to take off. If you're remembering the plus minus, you're ahead of the curve. Most people don't. And there's no imaginary here because the negative became positive. This was a word problem, number 40. I'll read it. I actually have this with me now. After 10 minutes, the amount of marbles in a magic bucket numbered 35. And the magician watched the number of marbles double every 73 minutes. Marbles as a function of time may be written as m of t. All right, so after 10 minutes, well, after 10 minutes is actually going to be an x minus 10 statement. Okay, and I have 35 marbles. I started with 35 and they're doubling every 73 minutes. So if I put 10 in here, I get 0. Anything to the 0 is my initial amount, 35, right? Oh, so that's my initial amount. So after 10 minutes, we saw it double. That's kind of awkward language on my part. I don't like the way I wrote that. I much prefer saying there have always been, let's say somebody starts with $50. This is what I should write, $50. It doubles. Starting in 1999, somebody put it into a bank account and it doubled. It doubled every 27 years. I'd rather have a word problem. I think this one was a little awkwardly written. So we're not going to spend any more time with it. We're going to go back. I wish I had a switch here where I had the camera for Rene Descartes because I'm backing up. I don't want to back up into anything. I might trip. I fall all the time. All right. So last series of questions. And remember, you're scanning. I should have said this halfway through. You go to where you need to go. You know how to do problems. You can always look at them quickly, how they're done if you want. Good practice. But getting ready for the test, you got 4 more times of doing the same problems. That's enough repetition for the ones you know how to do. It's spaced out nicely. So let's do these. 41, so I see 8/10 as 4/5. I wrote that. I know negatives can be rearranged in the other position. So I know x to the 4 I can write downstairs, in the denominator, x to the -3. In the numerator, there's one more x in the denominator. I can move the 7 up with a 15. There's your 22. I'm just going to fly through these now. All right, I know I'm going to multiply by 70 because these are prime. If I'm multiplying by 70, that's going to get 14 times bigger. This one's going to get 35 times bigger. 14 minus 35, I remember doing that in my head, minus 91. Yes. And so that's minus 91. It's going to become positive 91 on the other side if I move it. Or I'm dividing by a negative 91. Maybe that's what I did. And then I left this over on this side. I'm going to multiply that by 10. That's 50. All right, so now let's do it out. Check that work. So 70. 5 goes into 70, 14. There's your 14x. 2 goes into 70, 35. There's your minus 105x. 7 goes into 70, 10. There's your 50. I would have done that. If I was doing it on paper, I moved the 50 to that side. I move the minus 91 to this side. And then I divide by 91. Looks good. This is pure recognition, right? This is an ellipse centered at 5, -1. Has axes, 3 to the right and left from the center. Gets us our coordinates, and we've been practicing finding those coordinates. How would I find those coordinates? I would let y equal -1. I don't have to consider that anymore, but I know 3 squared is 1, which gets me an 8. Oh, that's right, 3 in this direction, 8, still -1. Or I could have gone backwards and gotten -3 by putting a 2 in. How far is it from 5 to 2? 3 units to the left, still -1. So we've been practicing finding those coordinates. If I let x equal 5, then I can see that has to be either a 4 or -3, where am I? -6. Right? -6. How far is it from 4 to 6? 10 units. 10 units from top to bottom implies that I'm going 5 up and 5 down. Big clue there where I'm getting that 5. Now, if I multiply this out, you're going to start getting things like 4x squared plus 8x plus 9y squared plus 18y equals some number here. So we're going to have to do completing the square with some things other than a coefficient of 1, which is why it's so important to be able to do a coefficient of 1 correctly, because we're moving up to harder problems in the second half of the term. Just a little shout out for trying to get as many problems in your pocket right now as possible. Still going to be working with the others, but be nice. Be nice. I know Alex in class can tell me that's 0.4 right off the bat, just looking at it. Same way I am, because he came to math help on a Thursday night, and we spent 5 minutes doing these. He's real good at it now. 3/2 could have been written in E notation approximately as e to the 1.1 over e to the 0.7. What do you do with the exponents? Because this is all about the exponents on top of e. And I think the exponents on top of e are 1.1 minus 0.7, and that's your answer. 1.1 minus 0.7, 0.4. And we want to get good at that because the rules of logarithms are happening here. This is the same thing as the ln of 3 minus the ln of 2. There's your first rule of logarithms. There's your 1.1 minus 0.7. So subtraction implies division. And I hope you can see why. I'm dividing, so the exponents are being subtracted. I'm showing you the exponents being subtracted for that division. Wow, I didn't expect to do rules of logarithms until after midterm. I just did. Won't be on your test yet. It's organically on your test. And I want you to do that for a while so that this makes more sense. All right. Didn't expect to say that, but it's time. Okay, that's done. So we're almost done. All right, piecewise function. I see a V shape down. I see x minus 6 changes signs at x equals 6. So therefore, I know that when x is less than 6, I am on the upside following this graph. The upside is positive 2. Get a little more room here. Alfred Hitchcock. Positive 2, change the absolute value signs to parentheses. And that's this branch. This branch is 2 times x minus 6 plus 1. If you don't believe me, Let's go with the y-intercept. Well, this is going to be -2. X minus 6 plus 1. So that's going to be -2. X minus 6 plus 1 as soon as I get past x equals 6. All right, and there's the pieces. If you don't believe me, let's get the vertex. 6, -1. +1, excuse me. So I don't need the plus sign. 6, 1. Throw a 0 in. Oh, 0 was on this side. So I should have done that before. That's on the increasing side. So 0 is going to get me -12 plus 1, -11. 0, -11. So equation of line, how do you get from -11 to 1? You go up 11. Oh, go up 12. I was thinking there. How do you get from 0 to 6? You change by 6. Well, that's a positive slope. That's a positive slope on this side and negative. When I'm on that side of 6, I'm on the positive slope. When I'm on that side of 6, I'm on the negative. Those are the pieces. All right, did I do this one out? No, I'll do it out. Just looking at it, that's going to become x squared plus 4x. 4, so, excuse me, 4 and 25 should be 29. Let's do it out and see if I'm right. So I'm going to bring that to this side. I'm going to leave that on this side. I'm going to square this. There's my x squared plus 4x plus 4. I'm going to square this. There's my 25i squared. What is 25i squared? -25. If I bring -25, if that's -25 and I bring it to the other side, I get that answer. All right, 47, last problem. We will not be asking you to do the sine of 29 pi over 6. We will, however, be covering it after midterm. Okay, we'll cover it. And you need to look at the intro to the unit circle. Because we're going to jump in real quick. I'm not going to lecture on that much. I already have it on a video and I take a lot of time with it. And we practice several problems. I need you to do that work before you come back from a midterm break. You got to be able to do these things in 3 to 5 seconds if you're really going to go up the ladder. And in order to do that, you have to have pictures in your head. And we're going to spend the second half of the term getting good pictures in our head. All right, so look at that video. I am going to ask you the point of inflection of a cubic because we're going to start working with cubics more in the second half. And I'd like you to know that cubits have a pattern that emanates from there. And you probably haven't heard concave down much. That's a shape. Concave up. Shape. And where it changes is what we call the point of inflection. And it's as easy to find as the vertex of a quadratic. Instead of minus b over 2a, you're working with minus b over 3a. Still the average of the roots, which comes from taking a cube that has different side lengths, adding up the putty and dividing by 3 gets you point of inflection. I can show that very quickly here. I think I will. I did a video where the intersection 0, 2, and 10. Hope that looks like it's 10. And the graph of the cubic looked like this. And where is the point of inflection? It turns out it's right about there, and that is 4. And what is 0 plus 2 plus 10 divided by 3? 4. So minus b over 3a, we have 3 sides to the geometry of a cubic. It plays a big role in evening off the sides of cubes that are not perfect cubes. So minus b, can you see down there? Yep. The opposite of -9 is 9. I obviously have a can problem. 3 times 3 is 9. That allows us to do a very quick plug 1 into the equation. If we plug 1 into the equation, you will get a 3 to 1 size with an opposite. So if that's -1, then that's going to be positive 3. A 3 to 1 opposite ratio. So a -3 to 1 ratio. There, I said that better. Grammarly corrected me. I got the chip planted in the head now. Yeah, it showed up. Grammarly showed up. Told me rewrite that for clarity. Yes. So let's look and see if we get that -3 to 1 ratio. Plug a 1 in. My first number is 3. Plug a 1 in. My next number is -9. Oh, there's my 3 to 1 opposite ratio. Put a 1 in, I get plus 10 minus 5. This number always gets doubled and change the sign when the numbers get bigger, right? I hope you can see double it and change the sign. 10 minus 5 is 5. So it looks like my point of inflection occurred at 1 comma negative 1. Now, let me just graph this for you quickly, just to see how I try to get a shape out of this. X squared plus 10x minus 5. All right, so keep that in mind, 1, negative 1. I start with a y-axis, and I go to negative 5. 0, negative 5. I also know that I'm going up at 10 to 1. But this is going to give it a bend. How much of a bend? I don't know. But I do know at 1, I'm at negative 1. And then it's going to end up going up there. Now, I would need to know the rate of change here. If the rate of change is negative, then I've got something that goes down and goes up, right? And it's not hard to get that rate of change. It's just c minus 3a h squared. Not going to have it on the next test. Don't worry about it. And then I'll find out right now whether or not I have maximums, local maxes, and local mins. So c is 10, minus 3, a is 3, and h we found is 1, 1 squared. And it looks like I have 10 minus 9, which is 1. So this never did go down. So I'm at negative 5, going up at 10 to 1, going up at 1 to 1. That's what that graph's going to look like, just by doing a couple of simple things. All right. And we will be doing a little bit of work with the cubic point of inflection. We'll see how much more. Putting cubics in graphing form, I don't think is in the textbook. So can't hold you too responsible for it, other than I think it should be there. And I think we should be studying it. And that I am responsible for, because I'm here to try to teach you to think mathematically. And hope I'm doing that. All right, so there we go. That's got that. That seems like a long video. You scan through it where you need to go. I'm getting practice every day from doing these on the board with students. And that's why I'm so familiar with it, because I just keep working with it, and working with it. It's not native ability. I've seen students with native ability. Yeah. All right. Have a good one. Oh, I love the ending now. Stay safe and warm. We got Yasser to thank for that one. All right. Thank you, Yasser.